All right, this is question number 15, take 2. Prove the identity below for all permissible values of x. So the identity is sine squared x over secant x plus 1 equals cos of x minus cos squared x. So in this identity, the first thing you want to do is analyze both sides of the equation. So on the left side, we got a sine squared over a binomial involving secant x plus 1. On the right side, all we have is the trig function cosine. It's a difference cosine of x minus cos squared x. So we should always start with the more complicated side. So in this case, dividing by a binomial is more complicated. So if we glance at our formula sheet, there's a few things we want to do. We want to keep in mind that our right-hand side totally involves cosine. And the neat thing about this identity is it gives us the answer. We want to start with the left-hand side, and we want to end up with whatever we have on the right-hand side. So the first thing that I would do is try to change secant squared of x in terms of an equation that involves cosine. So our equation, of course, that we could use, and I'll write this down, but it would be on your formula sheet, is sine squared x plus cos squared of x equals 1. So if we solve for sine squared x, we get sine squared of x equals 1 minus cosine squared of x. So this isn't part of our solution, but it's certainly what we want to use when we're starting this. So instead of saying sine squared x, I am going to write 1 minus cos squared x all over, and now the bottom is secant, and that's an easier one. That's a reciprocal function involving cosine. So it's 1 over cosine of x plus 1. So here's our first step. So although it looks more complicated, at least we have it in terms of cosine. So the very bottom, now we want to get a common denominator, and our common denominator for the bottom fraction is cosine of x. So we're allowed to multiply by 1. So I'm going to multiply this by cosine of x over cosine of x. So on the very next line then, keeping that in mind, we have 1 minus cosine squared of x all over 1 plus, so we already have a common denominator cos, so I'll write that on the bottom. And 1 times cos is cos. So we are making some progress here. So instead of dividing by our expression, I'm going to take the reciprocal and multiply it by it. So the initial expression, the numerator, is not changing. And if we take the reciprocal of this expression, it's cosine of x over 1 plus cosine of x. Now, it's just a good habit to keep brackets around our binomials. Now we have a situation that happens quite frequently. To eliminate 1 plus cos of x on the bottom, if we kind of know what we want to do, we can see that this is a difference of squares. 1 minus cos squared x is a difference of squares. So we can treat it as 1 minus cosine of x times 1 plus cosine of x. And just to remind you, right, this difference of squared is a squared minus b squared equals a minus b times a plus b. So we have a very, well, a is not too fancy, it's just 1, and b is cosine of x. So that's where that comes from. The rest of our equation still stays status quo, cosine of x over 1 plus cos of x. You can only cancel when you have multiplication and division. And by canceling, what we mean is, they will give 1. Okay, so we can cancel 1 plus cos of x and 1 plus cos of x. So we're almost there, I believe. What do we have so far? We got 1 minus cos of x times cosine of x. So we can distribute, and we get cosine of x minus cos squared of x. And we are very happy because we get the right-hand side. So I don't particularly like the way they set this up on the exam with the column, because we don't have to do anything on the right-hand side. Because we got it done, and we took the left-hand side, we showed it equivalent to the right-hand side, we are finished. The one thing that they don't ask us is they just say for all permissible values of x. Sometimes they'll say, identify your non-permissible values. And I'm going to do that right now just to show you. So we don't have to do anything on the right-hand side, but I do want to show you one step. When we say 1 over cosine of x, we know that you can't divide by 0. So at this point in the identity, if they ask for it, you could say cosine of x cannot equal 0. Because if cosine of x equaled 0, we'd have something that is impossible. And the general solution for that, if you think about the cosine graph, is pi over 2 plus pi times k, where k is an integer. Okay, so this solution is valid. The identity, the proof that I've shown is valid as long as x does not equal pi over 2 plus some multiple of that. So some odd multiple of pi over 2.